Hello everyone and welcome. My name is Eric Coleman with IIST and I'll be the moderator for today's webinar, Mobile Test Automation Covering Unique Functionality by Michael Udanin. We're excited you're able to join us today. Set aside an hour to attend this webinar. This webinar is sponsored by IIST, the leaders in education-based certifications and training. For more information on how IIST can help you or your organization, please visit testinginstitute.com. This webinar is a preview of upcoming live online mobile training courses that Michael will be presenting. Mobile compatibility testing on May 9th from 9 a.m. to 4 p.m. Central Standard Time, and mobile test automation from May 15th from 9 a.m. to 4 p.m. Central Standard Time as well. To learn more about this and other live online courses, please visit testinginstitute.com. You may submit your questions at any time by using your question box in your GoToWebinar window. Today's presenter will answer as many questions within the time allowed at the end of today's session. This webinar is being recorded and will be made available for viewing within 48 hours at testinginstitute.com. At the end of today's webinar, you'll be asked to complete a short survey. At IIST, we strive to provide the highest quality educational resources for the public and would appreciate it if you could take a few minutes to complete this short survey. I will now turn the webinar over to today's presenter, Michael Udanin. Michael?
Thank you, Eric, and welcome everybody. I'm excited to deliver this webinar to you. Mobile test automation covering unique functionality. So here we are taking a glimpse into one of the topics from a larger class that I teach, mobile test automation. Right? This class, mobile test automation, will take place on May 9th, 2017. 9 a.m. to 4 p.m. Central Standard Time, right? It will be an online class, but no worries, you will have breaks in the middle. We also teach other classes in mobile testing, for example, mobile compatibility testing. While this is not a topic from this class, it certainly has direct relevance to it, and we have another recorded webinar which gives you a glimpse into that class. I would suggest that you go to testinginstitute.com online, live interactive PHP, and you can find a whole list of our classes in all areas of software quality assurance and testing. Without further ado to our webinar. First, I will touch upon the unique functionalities of mobile devices to prepare sort of the playing field so we know what we are talking about, what kind of functionality I want to tackle. Then I will talk a bit about mobile test automation. Of course, it's impossible to cover even 10% of this subject in 1 hour, probably much less. Fact is, we have a whole class on that. But I will stop here and discuss briefly the main methods we can do with mobile test automation, and then the main purpose of the webinar, bringing it all together. How we can use mobile test automation methods to automate not only things like clicking a button, making sure the image appears, but unique functionalities of mobile devices. And mobile devices have quite a few. You have orientation, for example, geolocation. We'll go into both in a bit of a detail. You have gestures, where you can use 2, 3, 4 fingers sometimes, turning, pinching, and so on, to do a variety of functionalities. All those are fairly unique. You wouldn't have it on your typical PC. It is true that with touch screens, PCs and laptops are moving in this direction, but it will probably take years before they get there, and arguably people will never use as many gestures on regular PCs as they do on tablets and smartphones and other mobile devices. Internationalization, where you very frequently can change your phone, let's say, going from US to Canada, from miles to kilometers and back. Right? Scanning. Mobile devices are very frequently used to scan barcodes, to scan checks, to scan passports, and many other things. Optical character recognition, where you can train the camera of your mobile device on a certain text. It will read it, turn it into an electronic text, and store locally as editable electronic text. More and more, this functionality is also used for translation. You train it on, let's say, a menu in Italian. It reads it, OCRs it, does optical character recognition, translates it into English, you can read it right away. Right? Embeddedness in the business process. Mobile devices rarely live alone. They're usually part of a larger business process. Now, some of those functionalities, it's notoriously hard to automate, for example, gestures. Trouble is there are others which are excellent candidates for automation. We need to automate them, and it's not obvious. Think about orientation, right? With orientation, we change the device position, vertical position from portrait to landscape, and many applications would redraw the screen, would present menus in different order, and so on. Now, this seems to be a very common functionality, but those of you who work with mobile testing, and specifically with mobile testing of Android devices, know that there is a big landmine here, in fact, a whole field of landmines, and here it is. This operation, which seems rather innocuous, is very computationally intensive because we need to redraw every pixel on the screen. We need to redraw every single position. We need very frequently to change how the objects are presented. Sometimes we change the background image and many other things here. As we know, any computationally intensive operation might expose memory leaks into the underlying functions. Memory leak is a situation where a certain function deep inside the code grabs a piece of memory, which it uses for its calculations, and never releases it. In the times of assembly and classical C and C#, we had pointers. Today's more popular languages don't really have pointers, so it seems like, well, we solved the problem of memory leaks. Not so. Those functions written 10, 15, 20 years ago and reused and repackaged still might have memory leaks. You exercise this function 300 times, you don't really see a memory leak yet because it's tiny. But let's assume that this function is exercised every time you redraw a pixel on the screen. You do it 20 times, and boom, the memory space allocated to a certain application has been exceeded, the application crashes. Now, why it's particularly relevant for mobile? Because people carry devices in their pockets. They stand up, they walk, they sit down again, and this way throughout the day. Moreover, they turn the device in their hands, they put it in the car, frequently changes from landscape to portrait. Now, for many purposes, for many applications, you would not switch the application off. Think about application that does barcode scanning in a store. Think about an application which shows you the video. Think about the application which you need to, let's say, take pictures of houses and upload them, real estate application, right? Now, all those potentially are exposed to memory leaks when you change the orientation. Trouble is to test it manually. You need to turn the device back and forth and back and forth and back and forth, and this way, let's say, 300 times to expose a memory leak. I haven't seen one test engineer who would do it yet, at least without having significant wrist problems. This is a classical candidate for automation. It's a repeatable action with a relatively simple validation. Very little intellect goes into validating that your application is still alive after turning it 300 times. That's what we need to automate. It's hard to do manually if possible at all. Trouble is, how do we do it? There is a smack of hardware here. A challenge indeed. Another one is geolocation. Now, all of us who have smartphones use this wonderful type of functionality. Here, our device will serve as location-dependent functionality. For example, show where we are on the map. For example, pull data from a variety of databases based on your location and present you, for example, all the local restaurants or the local parkings, right? Just recently I've worked with a certain automotive company, and they want to rebrand themselves as a mobility company. They develop a fabulous little application where not only it will show you all the parking lots nearby, it also will communicate with many of them and book a place for you. So you arrive there, you don't need to look, the place is reserved, and allow for payment. Now here, you move from one state to another, one city to another, one country to another. You might well be pulling data from a different API now based on your location, right? There are things like applications which have a location inside the store and allow the associates to work with whatever is there, and many, many other functionalities dependent on location. Now, if I want to test one, it is not enough for me to move around New York City. I want to make sure that when I am in Alaska, it pulls data from a different database. When I am in Singapore, it selectively offers me the list of services available for this location, right? Some applications may be subject to legal restrictions in certain locations. For example, think about commercial applications. Let's say that they are allowed to sell their wares in 5 countries, but not another country, right? Some restrictions might be even by US state or Canadian province, right? It might switch automatically to different measurement system going from one country to another. For example, think about an application which automatically calculates your mileage and your reimbursement. Going from US to Canada, the rate can change, but the measure itself, mile to kilometer, might change as well. Right? So a lot depends on geolocation, and we need to run a real test here. I don't want just to cheat the device and send somehow the another coordinates programmatically and then hope it will work. Every test engineer knows why. I want to test it as close to the real situation as possible. I want to go to Canada, in a sense, to test it. I want the device itself to get the coordinate and pass to my application, and then see that it works correctly. Trouble is, most of the testing departments wouldn't sponsor you going to Canada or Singapore or France or elsewhere, right? How do I recreate Canada on my desk? This is also kind of functionality that I would want to automate, and why? Again, it's dumb functionality. I don't need to think much, but a lot of repeatable stuff. You plan your tests, which countries do you need, which locations do you need, what are the expected results, and then you need to run through them. And you get manually tedious, and how it can be possible at all without travel. That's challenge number 2. And here's our challenge number 3, a very, very relevant one. I will start talking about barcodes here, but please keep in mind that all what I'm going to say is directly relevant to check scanning or to any other scanning, right? Let's say that we have an application which reads barcodes, finds the product in the database, and does price comparison. A wonderful idea for a consumer app, and I believe we have few of those. Let's think about an application which works in a warehouse where somebody needs to be holding a rail with one hand, like the guy in the example, and then scanning barcodes from a variety of boxes, right? But before we even get there, we have 2 types of barcodes. Barcode, real bars, and they have different fonts, size, thickness, so on, and QR code, where we have a square which can pack more information than the same size barcode, right? We have different paper, blue, green, red, yellow, different lighting conditions, and many other similar things. We even have a distance from the barcode. Might have other physical limitations. To test my barcode scanning capabilities properly, especially in an application that runs on special hardware, let's say Windows CE, there are still quite a few of those, right? I need to recreate at least some of those conditions. Now think about check scanning, right? We have a banking app, and I would be hard-pressed to think about a bank which wouldn't allow this functionality today, and you should be able to train your camera on a check, scan it, and then your program reads it, runs all the necessary transactions, deposits the check into a bank account if it's a valid one and such, right? Now here, to test it properly as a good test engineer, I would think about different kinds of checks, different background color, background image, yes, no, whether I need handwritten checks, and so on and so forth. Analysis is very similar to barcodes, different factors from which we build our testing matrix, equivalence partitioning, all what we know from regular testing. This is also kind of test that I want to automate. Sitting there and scanning 300 checks, because realistically I have here numbers in the hundreds in terms of the relevant parameters. Large font, small font, black, dark blue, backgrounds, and so on and so forth. Okay? Doing it manually is not mission impossible, but something which will take a lot of time and very little brain power of yours. So here then, I want to automate it. The thing is, how can I automate it? Right? Another challenge. And now let's switch gears for a few minutes and talk a bit about mobile test automation. I wouldn't be able to go as much in depth as in the class itself, but I will still cover some bases necessary for us later to see how we can automate tests for those tricky functionalities, and not just for, click a button and see a pop-up on the screen. First, I will address emulators, which is one of the most unfortunately common ways to do mobile test automation. Then I will talk a bit about hardware modification, instrumentation of different kinds, and remote control. These are the four main methods people use today. Some are more common, some are less common. With emulators, the idea is very simple. You have a piece of software which you install on the PC. This piece of software emulates your device. It's supposed to behave as if it were the real device. The majority of emulators in the market are frankly total scam. Most of them are given to you for free, but they don't emulate the device, they just look like the device. Because what I want here is something which will run the operating system of the device. I want something which will create, let's say, a virtual machine, and inside this virtual machine run iOS or iOS 10 or let's say Android Nougat or whatever else. Right? Now, some emulators are a bit closer to the reality. For example, the standard Apple emulator, which naturally runs on Macs only, right? Or standard Android emulator. But in every single case here, no matter who created the emulator, we have one big advantage. It's easy to install and manipulate. After all, it's your old familiar PC, the same place where you run your automated script. But you have a couple of disadvantages. First, it's unrealistic. You're using the CPU of the PC, the RAM, the memory of the PC, and so on and so forth. As much as you try, it's not the real CPU of the device. And this is very relevant, specifically when you test computationally intensive operations, specifically when you test gestures, specifically when you test geolocation, right? You need sort of to cheat your device here, and how realistic it will be, my jury is out forever. There is another big problem with the emulators, and here it is. They are not always up to date on the latest patches to the operating system. And that makes perfect sense. Imagine that you are Apple, which would be a pleasant assumption, and you want to have a patch for your latest iOS. First, you will create it for your mobile devices, deploy it there, fix the problem. Usually people create patches to fix problems. Only then you will think about emulators. But that's exactly where I need my test automation to make sure that my software still works with the new update, with the new hotfix, with the new patch, right? So that's the problem with emulators, and that's why I confess I'm not a big fan of them. Another way to automate tests from mobile devices is hardware modification. It's a fairly old method, has been there for at least a decade. And here we take a device, have a picture of older devices here to emphasize it's an old method, but you do it with modern smartphones as well. You pry it open, your engineers study it, you hardwire it, and then through the internet you have a little interface on your PC which you can automate naturally, right? It sends signals to this special hardware and injects it into the device under test, and this is how it mimics where you clicked with your mouse or which button you clicked. Now this is how, for example, large labs like Device Anywhere work. There are hardware modifications today which are not really pry the device open, but play with the connectors of the device, you know, this little connection for, let's say, an iPhone, where you stick the power cord and the synchronization cord. From there they inject signals which trick the operating system to thinking that somebody is tapping the screen, right? That's how it works. Now that's a rather complex hardware, right? And there are a few advantages here. First, you have a real device hardware. The CPU is device's CPU. The memory is device's memory. Second, these kind of tools are usually maintained by at least mid-sized companies. Anybody who worked with small mobile test automation to vendors knows why it's so important. You need some support, some reliability here. There are a few problems here though as well. First, it's not realistic. Nobody carries a hardwired device in her pocket. And there are risks that the real device would work a bit differently when you really tap your screen with a finger. Or when the operating system gets the signal as if somebody tapped it, right? Rather than sort of hardwired, hardware stuff. Second, it might take significant time to add newly released devices to the lab. I mean, think about it. The engineers need to open it and understand how they work. Sometimes it will take 2 weeks. Sometimes it might take 3 months. And number three, highly complex hardware and highly complex software. Any test engineer knows that the more complex something is, the more frequently it will break. And that's a concern indeed. There is another way which is very common nowadays, and that's the instrumentation. I will start here with the classical instrumentation and then proceed to how more modern tools like Appium or CTES do it. The idea here is rather interesting. We have an application under test. It has buttons, it has windows, it has whatever it might have. Let's compile together with this application a little what they used to call hookup, a little piece of code which would constitute sort of a backdoor into this application. A little piece of code which would be like an API, the application programming interface, where you will send a command to it and it will tell the application, now click the button. Okay? Now type text into a field and so on. Right? Now, it is similar to the way, for example, Windows works. Instead of clicking buttons to open a window, you can just send a signal through a command line, open such and such window, and it'll do it. Right? So same here, a backdoor into the application, a sort of an API. Right? And then you can have a tool on your PC where you would say, okay, type IST into the search field. It will send a signal to the application under test. This little hookup, little piece of code, will find that field by the identifier and send the text there, as if the user typed it. Right? Now this has a number of very serious advantages. First, real devices are utilized. Number two, it has little load on device's memory and CPU. It's a tiny piece of code compiled with your app. It's not something loaded into the memory of the operating system, whatever. Number three, it's communication agnostic. Remember hardware modification? Now here we have very special hardware and software. Here, as long as you can send the signal through Wi-Fi, USB, other connections will work. And most of the tools in this area, they're communication agnostic. There are a few contrasts here. First, you change the application under test. And not only you change it, you also allow backdoor into this application. Imagine a banking app where there is a backdoor and somebody smart can send the signal to it, type something into the user and password field, or record what is being typed there. Usually when you release it, you remove this piece of code from your release code. However, if you forget to do it once, that's a security problem. So there is a risk. The biggest problem of this method, which is solved by more modern tools, next slide, is that you cannot open the application under test automatically. Cannot do anything at the device's level, for example, change settings. Why? Because you control only the application under test through this little piece of code compiled with it. Now this problem with some modern tools, for example Appium, is being solved. How? For iOS devices they have what they call UI automation. For Android devices what they call UI automator. And that's a framework which is compiled, which is working with the device's operating system. So differently from compiling a piece of code with your application under test, you have a piece of code which is part of the operating system itself, and thus it can open applications, close applications, work with settings, whatever you want, right? Same idea with UI automation and UI automator. Then you have a script which you've written, and you put there type IST into the search field or into field, let's say a TXT search, right? It sends a signal to Appium server. Appium server knows what you are using, what's your device under test, let's say Apple or Android. It compiles this piece of code in a way it would be fit for UI automation or UI automator, and then sends it to the app, and that works there. So in a sense, these are the advantages of old instrumentation without some of the problems, right? And that's a great thing. It's not the easiest tool to work with, but there are other tools that work in a similar way. Now, one disadvantage which is still left here is when the new patch to the operating system comes. It is not certain that the UI automation will work, for example, right? Because not necessarily Apple coordinates, the way they work with people who work on Appium server. With iOS 10 release, for example, there was a brief period of time when the scripts didn't work, and then, they fixed it. But it's certainly something of a bit of a concern. There is another way to do test automation, and that's remote control. People don't do it too frequently, but it has been done by large serious companies and rather successfully. I have to confess, done it myself even. Right? Here the idea is that you control the device remotely, the whole device. Just like you can control one PC from another, right? Remote desktop, VNC. You can do the same with all the major devices on the market, with the Apples and the Androids, and even with Blackberries you could do it, even with Palm Pilots. Now, to do it, you need to jailbreak iOS devices, and that's one of the disadvantages. Right? And I wouldn't go into the technical details here why, but in the class we certainly discuss it. Now, the beauty of that is that not only you utilize real devices, it has a little load on memory and CPU, you have a fairly small agent which allows you to control the device remotely, just like you do it on the PC with, say, VNC server, communication agnostic. You can use common automation tools here. We will get to it in a minute. Right? So all those are serious advantages. And all of them come because you decouple here the automation tool, remote control, and the application under test. How do you do that? Right? Well, for that, I prepared a little demo, and I recorded the video of this demo so you could see it. And what would be a presentation without a little demo? So here it is. I will run through it and talk about it. First of all, I want to run my test. I want to open YouTube on an iPhone, right? I want to search for videos and validate search results. How? I look for mobile test automation. My expected string is 553 to make sure I find this particular length video. I look for delta smoking not allowed. I find safety and so on. So here we have a device, a real physical device, and we are controlling it remotely from the PC. So I have a window on the PC which looks into the device. The device does the work, opens an application. It's reflected on my screen. It doesn't matter how I connect the device. I type something into the, I do something on the device, the signal goes to the PC, reflects it through remote control, right? I do something on the PC with my mouse, for example. The signal goes here, mimics the mouse click, and the device does the work. That's the important piece here. The real work is done on the real device. It's only reflected on my screen. And now, I can create a script, let's say QTP or another tool, which will send strings to the device through remote control, just like it can do anywhere, and then look at the image here, do optical character recognition of this window, and validate if this is the right image. Click on search, type something again, OCR the screen, read the strings, and see what we have got here, right? That's the idea. This is the way, in fact, we've worked with any interface where you cannot recognize objects on the screen. The script sees it, just like a big picture inside the window, and finds strings, can find color, can find location, and so on. The beauty of this technology is that it doesn't care what is the device. It doesn't know if it's iOS or Android or whatever else, what its operating system. As long as I can see the image on the screen, it will work. And then I can get the report, the exact good old way we, used to get the reports here, and such, right? So this is how the remote control might work. The main advantage is, of course, that we can have here we can have here total decoupling of the technology and the script. Doesn't matter if it's Android or anything else or iOS, as long as you see the image, it'll work. Moreover, you changed completely your technology. You developed a new technology. As long as it looks similar, it will work too. There are a few disadvantages here, of course. First, jailbreaking for AS required. I wouldn't go into the details what's so bad about it. We'll go into it in a larger class, but some people don't like it. I don't believe for all the good reasons, but some people don't like it. You need remote control software. Usually it's platform specific. Fortunately, we have some available even free, but it's still a concern, and usually this method cannot simulate gestures. And I will tell you right away, if you want to test gestures, if you want to automate testing of gestures, you better reconsider. The whole point of gestures is that you have real people's fingers. Some are shaky, some are not, some are thicker, some are thinner. That's what you want to test. But there are some tools which try to simulate gestures by injecting appropriate signal into the application under test, as if the gesture was made. Right? Now let's bring it all together in the last 15 minutes or so before I open up to questions. How can we automate tests for orientation, for example? Well, here we foray into a bit of hardware. And I feel very comfortable with this method because, guess what? I've done it myself. And if I can do it, any intern can do it. You hire an intern who studies electronics, it can be done. I never studied electronics, still did it. You build a little fixture which will turn the device upon computer commands. A computer here through USB cord sends a command turn at 90 degrees. In this little box you have what they call the servo motor, a motor which gets certain signal and turns, to a certain degree. The cost of building this device were close to $100, including buying all the ingredients. And so for buying all the ingredients, you can buy it in any electronics store. You can buy it as a variety of kits for high schoolers who study electronics. So you build this, you connect it to a PC, and then you develop a script, a very simple script, which will do the following. It will send the command, turn the device horizontally, 90 degrees, right? Look for certain things on the screen and you can use a script which works either as instrumentation or as remote control, right? And can get into the device and see what's in there. Or can get a picture of the device on the screen, as we did in this case. This device was connected to a PC screen through Wi-Fi. We were controlling it from the PC, so we turn at 90 degrees. We see another image. We validate that all the components are there. And we, let's say, click a couple of buttons to make sure the application responds. And then we turn it back again, and this way it can run throughout the night. And at the very moment when you try to validate that you have what you need on the screen and it is not there, and instead of that you're back to the operating system because the application crashed, voila, you log the error, grab a screenshot. Or you see that all the elements there, you click a couple of buttons, voila, application is frozen. Too bad, you log a defect. A device wouldn't get tired, would run through the night, would not have any issues here. You would never do it with a manual test engineer. For many applications, it is damn important to test this particular orientation functionality. Moreover, you can do it for multiple devices, for every release, and so on. Because frankly, this is what breaks in many computationally intensive applications. What do we do with geolocation? If you remember, the challenge here was to recreate Singapore on your desk. And that's exactly what I want to do. And I have a device which would allow me to do it. I can have a GPS simulator. And here I want to emphasize the big difference between what I call emulators and what I call simulators. An emulator emulates programmatically what we need to accomplish. Simulator simulates something physically. In this case, I have a hardware device called GPS simulator, which emits signals that mimic live GPS signals. It emits the actual radio wave in the proper frequency, which overrides the radio wave from the satellite. And then your device, not your application under test, but the device itself, receives the proper signal and thinks it's in Singapore. It's the same signal Singapore has. That's real simulation here. These devices are fairly smart. They allow full control over the signal, weaker, stronger, 3 satellites, 4 satellites, and so on and so forth. Usually need 3 to triangulate. That's why it's called triangulate, right? Good ones can also simulate GPS alternatives, for example, Russian GLONASS, Chinese Baidu, European Galileo, and so on. Why it's important? Because some devices, some Androids, for example, can get both GPS, the US system, right, which is, I don't know, 90% of users, not more, and another one, and this way find your location better. And you certainly want to test this case if this is the kind of devices on which your app needs to be installed. So this way you can run all the tests all around the world which you had planned. You develop a script which controls the GPS simulator, and all the ones that I know have PC interfaces. You don't need actually to play with the buttons and switches. You can do it all from the PC. A regular good old script, let's say in QTP, which would do it. And then you remotely control your device under test, which is laying right next to the GPS device, the GPS simulator, and see that it pulls the right data from the right place. That when you simulate Canada, it automatically switch to kilometers and to new rate for mileage, or kilometrage probably, if you're going for French, right? And so on and so forth. You can run all your tests here. Now, people frequently ask me, what about the people driving on the highway nearby? Wouldn't their GPS get messed up? No, it wouldn't. It works in the radius of 3 feet or so, 6 feet. So it wouldn't mess up people outside, don't worry. Right? Now, those devices are very worthy investment if you need ever to test geolocation. And since they have PC interface, you can control it through the very same automated script which you use to control your device, if of course your method and your tool are smart enough. And building smart methods and tools is something we definitely will discuss in our larger class. So here we have geolocation. And then comes scanning, and that's my favorite in this presentation. So here, I want to make sure that I run all the test cases that I need. If these are barcodes, for example, that I serve one barcode after another, or print one barcode after another, activate the device, and validate the scanning functionality. And that's another piece of magic here. This particular script, which I'll show you now, will generate barcode and print it on the PC, invoke scanning application of the mobile device, scan the barcode, validate the results by comparing scanned number with the original one. So I want here to generate different barcodes, maybe with different fonts, and have the device scan them time after time after time. Since I am the one generating the barcode, I control the expected result. I know which number should be read from the barcode. And this is how we do it. We have a rack with the device hanging there, tripod. That's one of the more expensive devices there, right? I control this device from the PC nearby. We use the remote control method. Here it is, controlling the screen. Then I have a printer, which will print and serve my barcodes. And the device will scan them. All this is controlled by my little script. First, the script will generate a barcode, right? Then send it to print, switch on the scanning functionality of the device, right? And then compare the results. So here we would fire the script. Okay. And look what it's going to do. First, it will open Excel, type a certain number, generate a barcode from it. Now, how does it generate a barcode? That's very simple. It turns the numbers into the barcode font, right? And now I'm printing the barcode in the printer. You see it's getting out from there. And I'm activating the scanning functionality here on the mobile device, right? So it's trained on the barcode. We are activating scanning functionality. It's supposed to be able to scan it. Here it's scanning it, right? Translates it into a number. That's the whole point of scanning the barcode. Okay? Now I will read this number through optical character recognition from the screen and compare to the one I generated in Excel. If it is the same, I will pass my test. If it is not the same, then alas, I wouldn't. Right? In this case, as you can see, it's the very same number, but I can grab screenshots. I can provide a very nice test report, all the advantages we have for test automation. Right? Same idea here. Right? Same idea here. Right? But a more sophisticated functionality. Now let's think about it for a moment. In this case, I don't have to print the barcodes. I can just make the printer sort them one after another, print nothing and just push the blank page. I have a whole library of them, 300 of them, sort them one after another. As long as I know the order and I control the order, I know it, then I know what my application should get. I can do the very same thing with the checks from the bank. I can have a library of those checks, let's say glued to pieces of paper so it's more convenient for printer to serve them, and serve them one after another, scan them, validate the results. I add another check to my library. Let's say we had a complaint from a customer to our support that a certain check couldn't be scanned. If our support is smart, they would ask to send this check to them, right, and reimburse the customer, of course, and we add this problematic check to our library to test it with every single new release. How we do it? Well, we sort them through an old ink printer or whatever, right, inkjet printer or any other printer, just push it out, right, and then we scan it, validate the results, right. This is another test which is really hard to do manually, if possible at all, right. Nobody would sit there and scan 300 checks probably. Relatively easy to do automatically. We just go here and do it, right? Moreover, in this method, I also can control the distance. I can hang my device on this tripod, it can be any other device, of course, higher and lower. I can put a little tiny tent around it and control the lighting and so on and so forth. All the variables which might be relevant, right? And this way, we can run a real test for physical checks being scanned by physical device and automated. And that's what I would consider the holy grail of test automation of mobile devices, trying to mimic the real usage conditions, the real GPS signal, the real turn of the device, the real scanning, and as you just saw, we certainly can do that. Now, to provide a quick summary, this class was this webinar was but a glimpse into a larger class in mobile test automation. What I was trying to cover here are the unique functionalities of mobile devices and how we can automate at least some of them. And they provided a number of test automation methods and discussed how we can use them to automate unique functionalities of mobile devices. As you probably saw, all the examples I brought up can be automated either by instrumentation method or the remote control method. Other methods are not as pliable. And that's indeed one of the advantages of those two methods. Right, with instrumentation and remote control, you can physically manipulate the physical device and achieve a variety of purposes here. Any questions at this stage? Any questions, one? Any questions, two?
There are some
chat, otherwise they wouldn't get to me.
Yes, actually they're in the questions panel there, Michael, if you want to go ahead and grab that. There's a few questions there.
Any questions, three?
Michael?
Well, Eric, I guess we have no questions.
Michael, can you hear me? Michael?
And Eric, I cannot hear you.
Michael, can you hear me now?
Well, this concludes our webinar. I greatly appreciate your attending it. Few words. Oh, I do have, there are a couple of questions. I just didn't see them. Okay, 1 second. I'm sorry for the technical problems here.
Michael, can you hear me now? Hello, if any attendees can hear me, can you please raise your hand? I wanted to figure out if it's Michael that cannot hear me or anyone else.
There are a couple of questions. I'll answer them in a minute. I'm sorry for the technical difficulties here.
Okay, so it does appear that Michael cannot hear me for some reason. Thank you for confirming that.
I'm sorry again. I'm trying to get the questions now. I know there are a few. I'll answer them all.
Michael, can you hear me?
First question. Please let me know what are the best automation tools for mobile testing, functional performance stress testing. Well, usually I don't give recommendations about specific tools. What I can offer you are some criteria and perhaps some hints to which tools might be, right? If you want to run a performance test for your server, right, not for the device, but for the server, then any performance test tool would do. The server doesn't care where from the transaction comes, right? If you want to do any kinds of performance tests, for example, volume test, filling the device with data on the device itself, then you need some kind of tool which tests device's functionality, can manipulate device's interface. Here you have tools which do instrumentation like Appium or C-test, very common. You can also use tools like device anywhere tools, where you access it through remote control and the device is hardwired. Device anywhere is one. Perfecto Mobile, which is frequently called Perfecto Mobile, is another one. They don't hardwire the device in terms of prying it open. They inject signals through the device's connection, right? You also can use tools like, let's say, QTP, good old tools, through remote control. It's more of a method than a tool. It has a bit of advantages, as we discussed, but it certainly can be used to remotely control the device under test when you, let's say, jailbreak the device and go there and do optical character recognitions and such, right? I hope I answered your question satisfactorily. Next question. I knew we cannot test in all the mobile OS. If I want to test in Android, what are the suggestions to the different versions of Android OS? That's exactly the subject which we cover in compatibility testing, both class and the webinar. In a nutshell, just like with any compatibility testing, you want to find a few things. First, what are the most popular platforms among your target population? You define your target population, can be the whole wide world, or can be, let's say, college students, or people of a certain company, and so on. At the next stage, you find out which mobile platforms they use. You can do it by looking up user statistics on the internet. We go very deeply in that in the compatibility testing class with examples and such. You can run user surveys and things like that. This will limit the number of platforms you need to address. The third stage is you find out what functionalities in your application under test are sensitive to the platform. Many of them are not. Everything that happens on the back end, you don't care what the device is. If you have 30 reports, but all of them use the same way to present them on the device, it's enough to test it once on each target platform, right? If it's, for example, a mobile website, then it's sensitive more to the browser rather than to device, unless it, let's say, uses GPS or so. So you don't need to run all the tests for it on all platforms. On the other hand, there are functionalities which you do need to test in your target platforms which you know from user survey. And these are, for example, display of buttons. That's always sensitive to the platform. All the functionalities which are relative to the GPS, for example, communication with the GPS and such. Right? Rendering of your screen on the device's screen, because they have different resolutions, different size, physical size, two different things, and also thing in iOS called retina display, which is very special. Right? Now this, standing on one leg, in a nutshell, the process of planning compatibility testing. Right? Last piece here is this. Even if you see that relatively few people in your audience use, let's say, the latest iOS or Android operating system version, you still probably want to test on it, because tomorrow that'll be the rule on iOS and in 2 weeks in Android. Right? So even if I see, for example, that iOS 10 just got out, well, it got out a while ago, but let's assume, and only 3% of my target audience use it, I still will test on iOS 10 because it's up and coming. Right? Hope I answered your question here, but much larger answer would be available in another class. Okay, so now here, which automation tool and process to verify performance testing scenarios? For example, a mobile application where many users would be logging onto mobile application. In this particular scenario, what you are stressing is the server and not the app, because different users open the app and log into the server. So here what I would do is this. I would have one mobile device controlled remotely using one of the tools that we discussed. And then I would have, let's say, another 300, 1,000 virtual users, like in good old performance testing, mimicking the devices towards the server, or sending the transactions to the server, which are just like the transactions sent from another 1,000 devices. And this way I would measure the performance on the server. As far as performance tools go, there is a whole variety. There is WebLoad and LoadRunner and whatnot. Right, quite a few here. The Microsoft tools. Oh, there are many. Doesn't matter which I use. So, and then on the device I automate in a regular functional way. Why do I need both? Because I want not only to measure the performance on the server, but also how it feels on the device, how quickly, for example, the device responds. The device's response has two components: the response from the server and the overhead on the device itself, which can be more or less significant depending how much data I need to process on the device to render my screen. Thank you for this question. That's quite an interesting one. Do you cover Appium in the course? I do mention Appium. I cover the way how it works, its architecture, but I do not teach in the course how to write Appium scripts or how to install Appium. Right? So this course is on mobile test automation, which is applicable to many different tools, not only for Appium. We do not teach Appium scripting in this class. Okay. I believe that was the last, I believe that was the last question. Well, thank you very much. It was certainly my pleasure to teach this webinar. Thank you. Eric?
Thank you, Michael, for your time today, and I want to thank everyone for joining us for today's free webinar sponsored by IIST, the leaders in education-based certifications and training. For more information on how IIST can help you or your organization, please visit testinginstitute.com. You can follow IIST on Facebook, Twitter, LinkedIn, and YouTube to find out more information about IIST news, events, and promotions. Thank you all again for joining us today, and have a great day. Thank you, Michael.
Thank you.